this video I will give a short introduction how to access the lab and also some background information about the infrastructure and how we virtualize the labs. To be able to connect to the lab, you need to be in the university network. This can be by Wi-Fi or by VPN. Then you have to go to the provided URL lab network garden, and you will be authenticated with the university account with single sign-on, and now you have a 5 hours connection to the lab. If this would be not enough, you can refresh your session and you get another 5 hours here. If you go down, we see some resources, some links. So we have a lab page, the cheat sheet, and 2 LTB servers. You hopefully know them already from previous modules. When we will work with the hardware, you have to go to the lab page, and then you see the 10 pods. You can select one of the pods and you can see if a device is on or off. We have 4 switches, 2 routers to emulate, and you can turn it on. You can connect out of band by SSH, VNC, and if you want to turn off the thing or reset, you have to activate the admin mode, so you see the reset button over here. And we can go back to the page here and open the cheat sheet. You already know this from computer networking modules, and here we can also have some documentation about the labs, how it looks physically. And now here we would see the LTB lab topology builder. This is the tool we use to virtualize labs, and we will go through the lab topology builder in details now. We will work in these modules with the LTB tool. That's a separate cluster only for this module. For the virtualization of the labs, we use a self-developed solution, the lab topology builder. It is based on Python code. We have the control plane with Docker, with front-end, back-end, database, Docker containers for SSH access through the web browser, and then we have multiple nodes with KVM and Docker. We can run QCOW VMs, or we can also run Docker containers for clients, but also router and switches who are possible to run in Docker. We use Open vSwitch to connect the devices to create a topology, and yeah, this is developed at the institute. It started 2015 as a remote lab only with some Python Django for static configuration deployment on topology we used for our trainings. So topology was fixed. We had, I think, 10 labs, and then we could deploy different lab stories to the devices, and then there were troubleshooting labs and configuration labs with all the technologies. 2018, we then used 2 students to create the first version of the lab topology builder. In the beginning, we had technologies with ACI, OV, Netbox, Flask, and we were able to deploy VMs, destroy VMs, kind of the basic features we have now. Then 2019, 2020, it was time for a complete redesign. So everything was moved from Flask to Django with Celery, with multiple workers, with multi-tenancy, user permissions, and then we used KVM, Docker, and OVS. Also a completely new UI was developed in React. Another student's project added then the resource management and possibilities to schedule labs. And now the newest update, we are working, or actually I'm working not anymore at the institute, but now there is work going on for the LTB version 2, who should be completely working as a Kubernetes operator with customer resource definition, and of course with pods, containers, and VMs with kubevirt. I hope this will be released soon. I'm excited about this. new version of the lab topology builder. When connecting to the LTB, the provided credentials need to be entered, and we come to the start page where we are at the running lab, and at the moment there are no labs running on this cluster. Lab templates, where all the templates are stored. Because this is a shared account only for this module, we only see the module related topologies that we can spin up, the reservations, when a lab is reserved, when it will be scheduled. We see the task overview, finished, running, failed, or finished task, scheduled of course the first one, information about the tool, which version is running, the cluster itself. We have 2 servers at the moment in this cluster and no labs are running, so there is no usage. And here we could log out. To deploy a lab, we go to the lab template and we have to select the right lab. At the moment this is set to read only, we cannot deploy it here, maybe it will be changed. We can now, in this dashboard of the shared user, we can create a new lab and then we can duplicate an existing one. We go here, we say we want to have the MPLS, call this MPLS 24. We can create it. If you need a special copy for you because you want to change some parameters for the startup, all these devices have some startup config already configured here. On the Linuxes we have Cloud Init where we can use, and this can be edited so everyone can have his own version here if needed. We go to run, we give this lab now a name, and I say I want to have it from the 7th until Saturday. If we go down, we will see it will deploy now. It takes some minutes until it's up, and it will be destroyed on Saturday night, and we deploy. Now we see the reservation is created and it will be deployed. If we go to task, it's already running and then it will show up here. If you want to create your own lab for any reason, we can also go to the dashboard, create a new lab, start from scratch, give a name, and now here we can create a completely new lab. We can go to add devices. We can take, for example, an internet, put it here. We can go here, we can select an Ubuntu machine, so virtual machine. We can put it here, but we can also use a Docker container like the Network Ninja with a couple of tools. Put it here. We can make connections, and then we can save. Now it is saved, and then we can go back to the lab template dashboard and we see it here. We can now edit it again, and if we go inside a device, we can add here the running configuration. If it is a Linux like in Ubuntu, we have to enter here YAML cloud config. You will find this in the documentation I showed. Or if it's a Cisco device, you have Cisco configuration. If it's another vendor, you have other configuration, and it will be loaded when the lab is deployed. And of course we can change the name here. Save again, can go back, and we go back to the running labs. I pause the video shortly, and as soon as the lab is deployed, it will appear here. Maybe you have to refresh, but normally it appears automatically. If we click here, we see now this lab is running. We have here the internet connection layer 2, so all these interfaces connected here will get an IP by DHCP. We have a Ubuntu server here, and here we can connect to the device with SSH and Web CLI. Important is this is out of band, so in this case of a VM we connect directly to a console. To the router we connect to the serial interface. It is an SSH connection, but it is by KVM mapped to the serial port, so please don't use this information here for any automation, because if we go to a device here, we open the web CLI, we're on a router, enable, you can say show IP VRF for example. Then we see we have here management VRF for this gigabit interface 1. And we see already IP addresses are configured, and here this gigabit Ethernet 1 in this management VRF has the IP address .7 by DHCP, and when we go back, we can now from this device here, from this server, this is meant as a jump host or as a working machine if you cannot run your automation script locally, and connect to the device. Important also, this machine is not persistent. If the lab goes down, if the lab crashes, all the information from this machine is gone. So keep in mind, there is no backup. Please work with Git so that you all the time have your progress versioned and somewhere safe stored. You can also connect to the Ubuntu. Here it's ENS at lab, and we are connected to Ubuntu. Also here we see that we have an IP address .11. Both these addresses are available directly from your computer and works until the countdown from the VPN connection to the lab is closed. This 5 hours. When we have the IP address for the devices from the UI, we can use the normal SSH client to connect to the Ubuntu machine, for example. Now we are on the Ubuntu machine in the lab. From here, for example, I can also ping the core router who had the IP address 7. So I can also ping it. I can also from here then SSH to this router. That also works. So now I see the router. So I jumped from my computer to the Ubuntu machine. There I can run the automation. So here I can do some Python, I can install library, you have full root access on the machine, and you can do the automation here. But of course, if you have a good system, everything is set up, it's easier to work on your computer, and you have direct SSH connection to all the out of management interfaces with IP. Remember, don't use the SSH shown in the UI, because this is a SSH connection who goes to the serial port. And please use virtual environments for Python. If you have any question, please don't hesitate to ask in the Teams channel, and don't wait until the last minute. Thank you very much.